Okay, thank you. Okay, good afternoon, everyone. Well, my name is Belén Galán López, and today I will present my research on the ecomorphology, a study of Caribou distal phalanx using 3D geometric morphometrics. And this study provides insights into the past mobility patterns and habitat use of reindeer, contributing to paleoenvironmental reconstructions. Well, reindeer played a very important role in the subsistence of Paleolithic hunter-gatherer societies. Understanding their migratory behavior is key to reconstructing past human mobility and subsistence strategies. Previous research has debated reindeer movement patterns, highlighting their high ecological plasticity. In this study, we use an ecomorphological approach to explore how reindeer mobility and habitat influence their morphology. This study aims to analyze the morphological variations in Caribou distal phalanx to understand the relationship between habitat, mobility, and morphology. We investigate by using geometric morphometrics, as I said, whether morphology differs among mobility patterns, sedentary, migratory, or altitudinal, and habitats. These habitats are tundra, boreal forest, and mountain, and whether these differences can be useful for paleoenvironmental reconstruction. Our sample consisted of 55 distal phalanges from North American caribou, classified into the three mobility types I mentioned and the habitat types I previously mentioned. So, well, but before continuing, I would like to underline the difference between sedentary and the migratory group, because in this case, we don't understand the term or the word sedentary as we traditionally use in archaeology. In this context, or the context that the biologists used in Canada, the sedentary group means that they are performing less than 200 kilometers annually. So in this group, we can include woodland caribou from the boreal forest. They are forest dwellers, and their movements are mainly between 100 and 150 kilometers per year, depending on the caribou population. The mountain caribou, they inhabit the mountainous mature forest, and they perform between 10 to 40 kilometers to the calving sites. And then we have the migratory group. They perform more than 200 kilometers annually, with other two groups, another type of mountain caribou with elevational migrations in spring and autumn. And the distances are more or less between 140 and 240 kilometers only one way. And then we have the migratory woodland. Here we have two kinds of herds, George River and Leaf River herds. They are the classic open tundra from the classic open tundra and boreal habitats, and they perform long migrations with distances between 1,000, more than 1,000, less than 2,000 kilometers on average per year. So, okay, up. Is it moving forward or no?
No, it's frozen. Now it's okay.
Well, the map with the situation of every population. Okay. And, well, sorry, because it's something, okay, right now. Regarding the materials and methods, well, specimens were scanned using 3D laser scanner. We use 3D geometric morphometrics to analyze shape variation. Landmarks and semi-landmarks were placed on phalanges to capture the morphological differences. And these are the distribution of the landmarks. And the general process analysis was used to remove the norm shape variation, followed by multivariate statistical analysis. And the analyses were carried out on the complete configuration of the phalanx and also the articular plantar surface separately. But well, today, because otherwise it's too long, I'm going to focus just on the complete landmark configuration. Well, so jumping into the results, first of all, the regression of the allometric residuals on the dichotomous forelimb hindlimb phalanges revealed that there was no significant shape differences between forelimb and between forelimb and hindlimb phalanges, suggesting that the previous variations we observed at the beginning of the analysis were primarily due to size differences. So these results allowed us to combine forelimb and hindlimb for the subsequent statistical shape analysis. Then, regarding the size differences, Kruskal-Wallis showed no statistical differences between mobility groups. However, habitat category yield significant differences, specifically between the boreal forest and montane, and between the mountain and tundra groups that we confirmed with another the postdoc Dantes we did it after that. Then, regarding the shape analysis, the PCA revealed distinct morphological clusters corresponding to habitat and mobility types, and indicating an adaptation of distal phalanx morphology to different substrates on movement demands. The first two principal components account a little bit more of the 40 of the morphological variants, and overall, the migratory tundra group is clearly distinct, clustering in the negative regions of both PC1 and PC2. In contrast, the migratory mountain group shows a wide variation in its articular and plantar configurations, indicating substantial internal variability. The sedentary mountain group forms a tight cluster in the upper middle of the plot, especially distinct along PC2, suggesting that its members share similar morphological traits. Meanwhile, the sedentary boreal forest specimens are more dispersed from the middle to the right, with a slight downward tilt along the PC2, indicating variability in phalanx shape, and some overlap with the migratory tundra group. And the migratory altitudinal group occupies a moderate central position, reflecting a balance of the traits measured by both species. Our findings show that migratory and altitudinal caribou exhibit a more elongated and robust phalanges compared to the sedentary ones. These differences align with the movement patterns, where migratory individuals cover long distances in open environments, while sedentary individuals remain in more closed forested areas. Then, we tested whether differences between groups suggested by the PCA were statistically significant through a MANOVA, and the results show significant differences in shape according to habitat and mobility type, but also significant interaction between the two factors. And when the sample is pulled by mobility and habitat groups, significant differences were found between all the categories, respectively. Additionally, statistical analysis of the interaction between these two factors showed significant results, and pairwise comparisons reveal differences between all the subgroups. And then we performed a canonical variate analysis as well, and it yielded higher classification rates on habitat categories, with an overall accuracy of the more than 84%, and a kappa metric it's a very good value of 0.76. Well, these results confirm that distal phalanx morphology is influenced by mobility and habitat, and it can serve as a reliable indicator of past mobility patterns and environmental adaptations. And the adaptation of the phalanx to different substrates suggests that similar approaches can be applied to fossil specimens to infer past mobility patterns of extinct reindeer populations. And this has implications for understanding past human, for sure, subsistence strategies. And of course, further research, it's necessary, including larger samples and fossil specimens that for sure it will enhance our understanding. To find out more, here I leave you the reference of the article. And well, thank you very much. I would like to thank Nicole Torres-Tamayo and María Fernanda Martínez-Polanco for their support and valuable contributions. Thank you for your attention, and I will be happy to answer any question.